Okie dokie. This weekend I thought I'd make this brief because I know you've got bigger and better things to do, like Teacher Mother Special on Sunday. So I'm going to talk to you quickly and briefly about the volume and surface area of similar solids. Now we know that for similar shapes, including solids, we always have to have a scale factor. Okay, the key here is scale factor, right? Now the scale factor is your ratio of the lengths of your shapes, right? The scale factor is the ratio of your lengths, right? Well, if that's the case, what if I want to take a look at the ratio of the areas and the ratio of the volumes? Well, in a previous lesson, we learned that the ratio of the areas is always your scale factor squared. What does it make sense then that the ratio of your surface areas should also be your scale factor squared? Since again, the area is just the sum of all your smaller areas, right? So here's what we got, right? So for similar shapes, we have scale factor. Scale factor is for length, right? If I want to talk about the ratios, and I'm going to actually let me start over again with the ratio of the perimeters. Now perimeter is about length as well, correct? So shouldn't that just be the same thing as my scale factor, right? I'm going to call my scale factor A to B, okay? Right? If my scale factor is A to B, then the ratio of my perimeters is A to B. My ratio of my surface area will be A squared to B squared, right? The ratio of the volumes then, well again, let it make sense. Does it make sense for it to be A cubed to B cubed? Alright? Alright? So if I know the two shapes are similar, I know they have a scale factor. I know that the ratio of their lengths has to be, or the perimeters has to be A to B. The ratio of their surface areas has to be A squared to B squared, and the ratios of their volumes has to be A cubed to B cubed. Let's take a look at some examples of how I can use this. Ready? In this example, right? And again, I'm just going to go jump into the medium end of the pool here. If I told you that shape A, shape A has a lateral surface area of, say, 8 square centimeters, and shape B has a lateral surface area of 18 square centimeters, find the scale factor. And I'm going to abbreviate that to SF, okay? Well, again, so the first thing I want to do is I want to start off by trying to create my ratio of, well, since I'm given area, I'm going to make a ratio of my surface areas, right? So that my ratio of my surface areas, or the ratio of my areas in general, would just be 8 to 18. Oh, wait a minute, that simplifies to 4 over 9. Well, let it make sense. If that's the ratio of the areas, how would you go back to my scale factor? Yes, you would square root both sides. My scale factor must equal the square root of 4 over the square root of 9, so 2 to 3. Does that make sense? All right? Okay. And now I've found the scale factor, right? All right, let's pick it up a notch. Ready? In the next example, I tell you the ratio of the surface areas of two shapes, A and B, is 9 to 25. If the volume of A is 36 cubic units, find the volume of B. Now again, I'm giving you directly the ratio of the surface areas. It's 9 to 25, right? So my ROA, ratio of areas, is 9 over 25. Now I needed to figure out a missing volume. But to know volume, I need to know the ratio of the volumes. But to know the ratio of the volumes, I need to know my scale factor. So the first thing I'm going to do is I want to go backwards and find my scale factor. Well, again, to get from the ratio of the areas back to the scale factor, well, we just did that problem. Would it be the square root of 9 over the square root of 25, right? So that would just be 3/5, right? But if my scale factor is 3 to 5, what's the ratio of my volumes? Well, shouldn't it be 3 cubed over 5 cubed? Which we all know is 27 over 125. If you need to pause this video and think about this a little bit, then do so. Now, if those are the ratio of the volumes, this is A to B, correct? This is the ratio of A to B in the volumes. Well, you're told, though, that shape A has a volume of 36. So doesn't 36 over some volume for B, x, does that have to equal 27 over 125, right? Well, again, to solve this, I'm going to cross multiply. I'm going to multiply my two means, so 27x, to equal my two extremes, 36 times 125, right? Dividing both sides by 27, I get x equals, well, wait a minute, I know both of these have a 9 in them. That becomes, I can divide 27 by 9 and get a 3. I can divide 36 by 9 and get a 4. So I get x equals 4 times 125 as well, that's 500 over 3. So the missing volume must be 500 over 3 cubic units. Does that make sense how I got this? All right? All right, let's take one more example. Okay, so in this next problem, I'm told that shape A has a volume of 256 cubic units, and shape B has a volume of 108 cubic units. If the surface area of B is 45 squared units, I want you to find the surface area of A. Well, think about this. I'm starting you off by giving you the volumes of two shapes. So I know that the only thing I could make would be a ratio of my volumes. Now we start by taking the two volumes and just making a fraction. Now, that's not a ratio yet, because we know a ratio has to be in simplest form. So in other words, I have to reduce this fraction. Well, let's see, I think both of those can be divided by 2. If I divide 256 by 2, I get 128. Divide 108 by 2, I get 54. Oh, wait, this can be divided by 2 again. That becomes 64 over 54 divided by 2 is 27, right? All right, so I don't think that fraction reduces anymore, so that's the ratio of my volumes. Well, now, to go from the ratio of the volumes back to my scale factor, I got to go backwards. So what's the opposite of cubing something? It's called cube rooting. So I'm going to take this ratio of volumes, and I'm going to do what's called a cube root. That looks like a square root sign, but you put a little 3 there. And that little 3 says, hey, what number times itself 3 times gives me the number inside? Well, in this case, what number times itself 3 times 64? It's 4. What number times itself 3 times is 27? Well, it's 3. Okay, so now that I've cube rooted my ratio of volumes, I get a scale factor of 4/3. Okay? So now using this ratio of the scale factor, I can now take that and go to, well, I'm trying to get the surface area, aren't I? So to do that, I need to now take that and square them to get to the ratio of my areas, right? So if I do 4/3 squared, I come up with 16/9, right? And again, that's A to B, right? Well, in this problem, I'm told that shape B has an area of 45 squared units. So couldn't I say 45 over x? Well, I'm saying that boy. 45 is on the bottom, right? 45 is for B. I'm looking for A. That has to equal 16 over 9. Yeah? Again, A to B. A to B. Okay? B's on the bottom of the scale of the ratio of the areas. B's on the bottom for the 45. Right? Now cross multiplying, I get 9x equals 45 times 16. Dividing both sides by 9, I get x equals, 9 goes into 45 5 times, and 5 times 16 is 80. So it must be 80 squared units. And that is the scale of, that is the surface area of shape A. Okay? Hey guys, thanks for paying attention. Thanks for your patience. Have a lovely rest of your weekend. And remember, be nice to mother.